Welcome. Today we'll learn how to determine the sample size needed for estimating a population proportion using an example about public opinion on abolishing the penny. The formula we use to calculate sample size for estimating a population proportion is n equals z squared times p hat times q hat, all divided by e squared, where n is our sample size, z is our confidence level value, p hat is our estimated proportion, q hat is 1 minus p hat, and e is our margin of error. Let's first consider the confidence level. Common confidence levels are 90%, 95%, and 99%. These correspond to z-values of 1.645, 1.96, and 2.576 respectively. When we don't have any prior information about the proportion, we use p hat equals 0.5, which gives us the largest possible sample size. This is called a conservative estimate. Since q hat equals 1 minus p hat, q hat will also equal 0.5. Let's calculate the sample size needed for a 95% confidence level with a 3% margin of error. We'll plug in z equals 1.96, p hat and q hat equals 0.5, and e equals 0.03. This gives us 1.96 squared times 0.5 times 0.5, divided by 0.03 squared, which equals 1,067 people. Let's see how the sample size changes with different margins of error. With a 5% margin of error, we need 385 people. With a 3% margin of error, we need 1,067 people. And with a 1% margin of error, we need 9,604 people. As we can see, decreasing the margin of error significantly increases the required sample size. Researchers must balance the desire for precision with the practical constraints of time and resources when choosing their sample size.